right, so let's go through this given information. It says that FC bisects angle AFE and EB bisects angle DEF. So right away from the given information, from scanning it, I think a lot of our brains are going to multiplication or division. And then I asked a question. I asked, is there enough information to prove angle AFE, AFE is this angle, congruent to angle DEF, this one? All right, let's take a vote. How many people said yes, we would be able to prove that those two big angles are congruent? How many people said no? Why would we not be allowed to use multiplication to prove them congruent if you all are saying no? Because I had the double bisect. Why can't I just say they're congruent by multiplication because of the double bisect? Victoria?
Because we don't know any numerical values.
But in any of the proofs, we don't know any numerical values.
No, but nothing's...
You're still sticking with no? Yeah? Okay. Taylor?
Because, we don't know if the smaller parts are congruent.
There we go. We don't know if the smaller parts are congruent. So when we're using multiplication, don't we say, well, if the half angles are congruent, then the full angles are congruent? But do we know anything about the half angles? We don't know anything about the half angles. Since we don't know anything about the half angles, we can't make any conclusions about the full angles. So is there enough information to prove these? No. The answer is no. There is not enough information. Right. If I wanted to use multiplication, what additional information would help us out here to be able to prove those two angles? Let's call this 1, 2, 3, 4. Sienna?
Angle 1 is congruent to angle 3.
Good. We can say angle 1 is congruent to angle 3. Or what else could we say? Angle 2 is congruent to angle 4. Or I can say angle 1 is congruent to angle 4, or what else? Angle 2 congruent to angle 3. If we said any combination of those half angles being congruent, then we would be allowed to say that the full angles are congruent. All right, we are going to learn two new properties today. The first one is called the transitive property. There are theorems that go with the properties, but you just need to write down in proofs the word transitive. I will read you the theorems, but in proofs we do not need to memorize them. As long as we recognize transitive, we could just write that down. For transitive, I'm creating a chain of congruent things. It's a chain of congruent things. So for example, if I told you angle A is congruent to angle B, but I also told you that A is congruent to C, would we be able to conclude that B and C are also congruent, do you think? Yeah, why? Because they're both congruent to A. That's the transitive. It creates a whole chain of things that are congruent, and at the end you conclude more things that are congruent. So transitive only, I can't stress this enough, transitive only deals with congruency, nothing else. So it's a chain of congruent things, and then what do we prove? More congruent things. That is transitive. So the two theorems that go with the transitive property, first one, if angles or segments are congruent to the same angle or segment, then they are congruent to each other. That was like the problem we just did. They were both congruent to A, so they had to be congruent to each other. The other one is, if angles or segments are congruent to congruent angles or segments, then they are congruent to each other. Again, just a whole chain of congruent things, so then we conclude more congruent things. Okay, substitution is different. So with transitive, like I said, a chain of congruent things, then we're proving more congruent things. For substitution, your proof statement will never be of congruency. Your proof statement will never be of things congruent. So substitution is very similar to how we use substitution in algebra. You're substituting one congruent thing into an equation for something else. So here, if I tell you, let's skip this part. Let's go down here. The substitution properly, okay. If angle 1 is a complement to angle 2, what does that mean? If angle 1 is a complement to angle 2, those two angles do what? They add up to 90. Then it says angle 2 is congruent to angle 3. Our conclusion would be angle 1 is a complement to angle 3. And our reason would be substitution, and I'll explain to you right now. Okay, so angle 1 is a complement to angle 2. That means they add up to 90. We all agree on that. Then it says 2 and 3 are congruent. Well, 2 and 3 congruent, doesn't that mean they're the same measure? So if angle 1 plus angle 2 adds up to 90, since 2 and 3 are the same, wouldn't angle 1 plus angle 3 also have to add up to 90? So what we're doing is we're sort of taking this comp equation, angle 1 comp to angle 2. We're taking that comp equation and we're substituting in the 3 for the 2 since they're equal. That's substitution. Our substitution statement will never be that things are congruent. It will always be some sort of equation. It will always be some sort of equation. All right, are we ready for some proofs now? Let's do this. Anybody still copying? Okay, great. So I didn't draw in my little charts for you today. Gotta draw on our own. So remember, I don't write out the given in class, but on tests or quizzes, you have to write out the given. It gives you points on tests and quizzes just by writing out the given, so you want to make sure you do it. And now let's go through our given information and make conclusions where we can. So the first piece of given information is segment FG is congruent to segment KJ. Any conclusion I can make from that first statement? Nothing. Then it says segment GH is congruent to KJ. Well, KJ already has a slash on it, so I have to put the same marking on GH that's on KJ. So I'm going to put a slash. There's a conclusion we can make right now. Dylan?
Segment FG is congruent to segment GH.
Excellent. FG is congruent to KJ. GH is congruent to KJ. They're both congruent to the same segment, so they must be congruent to each other. So we're going to say FG is congruent to GH. What would be the reason, though? It's one word. What would be the reason? Sean?
Transitive.
Transitive, you got it. All right, we went through the given, we made conclusions. Now we have to look at what we want to prove. We want to prove that KG bisects segment FH. Well, tell me, if you're bisecting a segment, what do you need to show? If we're bisecting a segment. Lucas?
Two congruent
Angles?
or segments.
Good, two congruent segments. If we're bisecting a segment, we're showing two congruent segments. So if KG is bisecting FH, which two segments would we need to show? If KG is bisecting segment FH. Victoria? FG and GH. Did we already show that those two are congruent? Yeah, so we can go straight into saying that KG bisects segment FH, and the reason is def of bisect. All right, next problem. All right, so here we have angle 1 plus angle 2 equals 90. No conclusion to make there. Then it says that angle 1 is congruent to angle 3. And what is it that we want to prove? We want to prove that angle 3 plus angle 2 is equal to 90. Angle 3 plus angle 2 is equal to 90. Well, look at what we have here. Angle 1 plus angle 2 equals 90, and 1 and 3 are the same. If 1 and 3 are the same, wouldn't angle 3 plus angle 2 also have to equal 90? What are we doing? Because they're equal measures, I'm literally going to take angle 3 and substitute it into the equation. Oop, not for angle 1, sorry. Substitute it in for angle 1. So I can go ahead and I can say angle 3 plus angle 2 is equal to 90. What's the reason? What's the reason, do you think? Ever, Petus? Substitution. What do I want to point out to you? Look at my statement that goes with substitution. Is it stating congruency? No. Your substitution statement will never state congruency. It will never state congruency. It will always be some form of an equation. All right, number 3 is not a proof. Actually, the wording of number 3 is really good for Algebra 2. You'll see this kind of wording a lot once you go back to algebra next year. So here we have angle P is congruent to angle R, so I'm marking that. And then it says angle Q is congruent to angle R. Come to a conclusion. If P is congruent to R and Q is congruent to R, what's the conclusion we can make? P is congruent to R, Q is congruent to R. Selena? Good. Angle P is congruent to angle Q. If this was a proof, what would be the reason that angle P is congruent to angle Q? One word. Dylan? Transitive. Okay. So now we want to express angle Q in terms of x and y. In order to express angle Q in terms of x and y, that means we can't have any y's. Just x and a, not x and y. When it says express angle Q in terms of x and a, it means we cannot have any y's. So I need to think of an equation that I can use to manipulate things. Well, do we agree it said to us angle P and angle R are congruent? So since angle P is congruent to angle R, I can say that x plus y plus a is equal to 2y plus a. Do we agree? So when we say express in terms of x and a, basically what I need to do is I need to figure out what y equals. So I need to get y all by itself on one side of the equal sign and all the x's and the a's on the other side of the equal sign. So I need to get y all by itself. How am I going to do that? Well, first I'm going to subtract y on both sides. So then I'm going to have an x plus an a equals y plus a. What should I do now? Because I need to get y all by itself. Lucas?
Minus a.
Good. We're going to minus a on both sides. And what happens on both sides when we subtract that a? They cancel. So what does this tell us? X is equal to y. So when I say write in terms of x and a, every time I see a y, what am I allowed to put instead? X. We don't want y in this final representation. So we want to find angle Q. Well, we know angle Q is congruent to angle P, and angle P is x plus y plus a. Do we agree? But I want it in terms of x and a. So I have a y here. What should I do with this y? Lauren?
Change it into an
Change it into an x.
x. It would be 2x plus a.
You got it. So angle Q is going to be x plus a. So angle Q would be represented with 2x plus a. Did we represent angle Q in terms of x and a? Yes. No y's. Can we keep going? Okay. All right, we're going to go through our given and we're going to make conclusions where we can. So given that VW is congruent to RS, no conclusion there, and XY is congruent to RS, now we can make a conclusion. VW congruent to RS, XY congruent to RS. What conclusion can we make? Somebody new, somebody that hasn't participated today. So VW is congruent to RS, XY is congruent to RS. What conclusion can we make? Eleni. You got it. VW. Oops. Is congruent to XY. Who thinks they know the reason for this? Zia?
Transitive.
Excellent. Transitive. All right, let's keep going. We want to prove that Vx is congruent to Wy. We need to prove those two segments are congruent. You resting your eyes? All right, so Vx congruent to Yw. Tell me, what are you thinking? How can we do this? No thoughts? Only Victoria? All right, let's talk. Right now, we don't have Vx, we have Vw. What do I need to do to get from Vw to Vx? Wouldn't I have to add Wx to it? All right, and right now I don't have Wy, I have Yx. What would I have to do to get from Yx to Yw? Wouldn't I have to add Wx? So if I have two congruent parts and I add the same thing to both, are the sums still congruent? Yeah. So this is what property?
Substitution.
No. Want to try again?
Transitive.
Neither. No. Not from Alex? Addition. This is addition. But we got to put a step in between. Because aren't we adding the same thing to both? Like we're adding Wx to Vw and Wx to Xy. I had said there's a certain step we have to take when we're using it twice. Steph?
Wx equals Wx. I think it's reflective.
Reflexive. You got it. Wx congruent to Wx, and the reason is reflexive. And then we can prove what we want. Vx is congruent to Wy addition. Are we ready for the next one? Anybody still copying? All right, next one. All right, so here we have angle Q is a complement to angle QRS. So I'm going to put a star on Q, I'm going to put a star on QRS. Then it says that angle T is a complement to angle TRS. So I'm going to put a dot on T and a dot on angle TRS. So far, no conclusions to be made. Then it says that RS bisects angle QRT. Is there a conclusion to be made from that? Absolutely. What is the conclusion we can make if a segment RS bisects angle QRT? What conclusion can I make? I lost it. Hold on. Cameron.
Yeah, the two sides are congruent.
I'm sorry, I couldn't hear you say it one more time.
The two sides are congruent.
So you're right about the two. Two of something are going to be congruent, but not sides, because we're bisecting an angle, so we should get two angles. So you're going to look right in the middle letter, right at the vertex, which is R. Look inside R. Do you see two angles there? Could you name them for me with three letters?
QRS and SRT.
You got it. So we're going to now say angle QRS is congruent to angle SRT. And this reason, anybody know? Why are we able to say those two angles are congruent? No, more hands should be up. Tim?
Def of bisect.
Good, def of bisect. All right, now we want to prove that angle Q is congruent to angle T. Look at what we have here. Q is a complement to angle QRS. Angle T is a complement to angle SRT. And QRS and SRT are congruent. Didn't we learn a theorem that I made you take a do now quiz on about comps and their congruent angles? See ya?
Comps of congruent angles are congruent.
You got it. So we can say angle Q is congruent to angle T, and the reason is comps of congruent angles are congruent. Now we have three independent problems to do. I will tell you the steps. Independent number one is going to be two steps. And the first step is always what? The given. So it's two steps. The first step is the given. Independent number two. Hold on. All right, this is also two steps. And independent number three is four steps. So two steps, four steps. So go ahead and try those problems and then we'll go over it. Alright, let's go through this real quick. So, for the first and second one, I said they were 2 steps, right? For step number 1 is the given. And we have angle 1's congruent to angle 3, angle 2's congruent to angle 3, and 2's congruent to 4. Isn't this a whole chain of congruency? So we can say angle 1's congruent to angle 4. What's the reason? Transitive. How many people got that? Great. All right, next one. All right, I see double midpoint. Because I see double midpoint, what should I be thinking? Multiplication or division. Now they're telling us NP is congruent to SP. Well, if the whole segments are congruent, aren't their halves also congruent? What is that, big to small? Division. All right, now the last one. This was much more involved. Now here we have angle 1 is congruent to angle 2. That's all that's given to us. And we want to prove that angle 1 is a supplement to angle 3. As of right now, they're really far away. Are they supplements the way they look? No. But which angle is a supplement to angle 3? Angle 2. But before we can say that 2 is a supplement to 3, what must we declare first? Good, Zia. What'd you say? Straight angle. Can somebody name the straight angle for me using 3 letters? Step. M-A-K or M-A-R? MAR. Either one is acceptable. I'll go with MAR equals straight angle.
I read segment MK. Is that okay?
No. So segments and angles are different. You have to name an angle using 3 letters and the angle symbol.
Okay.
And isn't that assumed? All right. So now that I assume the straight angle, now I can say that angle 2 is a supplement to angle 3. That is not assumed. That is not assumed. What's the reason that angle 2 is a supplement to angle 3? Everpetus. Well, is that a sufficient reason? So remember, the reasons that we write down could never be problem specific. But we didn't say 180 here. We just said 2 is a supplement to angle 3. Good, Colin. Def of sub. All right. Now that 2 is a supplement to 3 and 2 and 1 are the same, can I say 1 also has to be a supplement to 3? Yes. What's the reason? Substitution. You got it. All right. We are done. Your homework is here. I will post it next period. Don't forget your phones. What'd you say?
We're trying to prove that this is congruent to this. Or we're trying to prove that this is a supplement, but we don't already know that. We don't know that it's already a supplement.
Drop something. Bye.
Exciting, right? Where are you going?